Hello and welcome back to module number 2. Before I will start talking about what is module 2 covers and what does it entail, I like to make sure that everyone is okay and all of us are getting to experience new reality, which is basically at home all the time. I hope you are getting used to it. I hope you are adjusting. In case you're not, or in case you need some help, USF offer that help. Please log on to USF hotline, and they will help you discuss with you or be able to share your problems with them, or problems or issues that you encounter. I highly recommend to do that. Okay, so what are we going to do in module number 2? We are going to cover basic terminology. I did not discuss in module number 1, I did not discuss what is the term visual analytics. And so we're going to cover that, but we're also going to cover basic design perspective that we as data trying to capture the data and trying to illustrate that in not only words but in visual graph, visual objects. This is require us additional skills and understanding of the medium itself, and I will try to cover that. So let's begin. Oops, sorry. And we're going to see a different application with that too. Okay, so visual analytics is not easy to define because it involves many fields, many technology, many aspects from art to science. And in early definition, the science of analytics reasoning is the idea of interactive human-machine interface. So the early definition was including the computer human-machine interface that was part of the terminology that it is used. Nowadays, when they are talking about visual analytics, they're also combining the automation analytic techniques and idea of interactive visualization in order for us to better understand the data and better communicate it with us as a human. So this is the paradox that often entail in visual analytics. But let's start, and this is important, let's start with the issue of design. What does it entail? How do we design data, and what does it entail? We remember in module number 1, I talked about different types of, there is data, there is knowledge, there is wisdom, and all of that needs to come down to rules and rules that we encounter. So when we have data, usually we also have some visual items that we are able to create. That is the points, the lines, the coordinate system, the numbers, the symbols, the words, the shadow, the use of shadow as another implementation of the design itself, and colors. This is based on Professor Howard Taft, and this is something that we will see, and we will see his implementation to data visualization. So what is a point? Even there is only one point, it marks on a large page, it makes a relationship or give some order to us. So it gives us the idea of orientation in relation to the outline of the page and relation to the data itself. In this case, it's one point. Line, in the other hand, marks by moving the point and having some impact on its direction. So it's not only a single point, it is a line that basically allowed us to make more representation of the data that is usually can be communicated through emotion and through a character and directions. And this is something that we will see along many examples. So line composition, and we see that quite often when we analyze large data sets where the lines are all over the place, and so there is the issue of line composition and where the line stands and how it represents. Circle is another way for us to apply and to capture the data, and we will see those examples. And of course, text. Text is where it usually apply, and we can convert the text into dots, or to convert it into circle, or to apply the text itself, and we will see some example of graphic design to text and how to do that. One of the things that's common nowadays is to use a background patterns, and which means that the patterns in the back has to change, and we will see that especially with Python and especially with RStudio, where we can change or create different. Even Microsoft Excel give us the option of different background patterns into that. The most important aspect is the issue of colors and the issue of how do we apply the colors. Example, I am from the Middle East, which means that in my nature or in my culture, I refer to specific type of colors in compared to people from Europe or people from Australia that likes different colors. So culture is part of the discussion we usually have when we are talking about colors, and we will see that in action. I want to start reviewing format, visualization formats. Example, by bar chart, line chart, pie chart, and scatter plots. All of that are part of things that we are often see, and Excel quite often use it and generate quite nicely. Example, bar chart. Usually it's a most common type of data visualization, and usually it provides us the ability to display different quantities of a single variable. Example, number of time I drink coffee. So daily I drink 20 cups of coffee twice a week, and this is the number, and again the growing number of coffee that I drink. Line graph is another way for us to capture the data, and it is usually the idea that the horizontal axis represent the time, and this is a way for us to capture the data. One of the things that is often used, and especially in data science, is coordinate grid, which means that they give us coordination where the data lies into the X and the XY, and this is something that is very useful, especially when you have a large set of data and you want to see where it all lies in this grid. A pie chart is also very common platform of the visualization, and it's really easy to understand the data and how, in this example, how much money is spent on the police compared to libraries, compared to park and recreation, on streets and code components. All of that is quite easy to understand. Scatter plots is also very popular nowadays, and it is usually allowed us to display it, and it gives us the ability to have a grid in order for us to show what is the relationship between different type of data set in that correlation. So one of the questions that often been asked, why not use Microsoft Excel and we don't need to go over all those applications that the professor is so keen about? So why not? So the issue is, and that's a question not only the students ask me, it's also my dad, my parents, and even the neighbors that knows what I'm trying to do. So the short answer is that Microsoft Excel does not allow us to do bubble chart, ring chart, distribution map, counter maps, and self-organized map known as heat map. Okay, so this is part of it. I will argue, and throughout the semester, I will argue that Excel has a problem when we are using large data sets, which means that he generates its own code, which is hard for us to detect what is the problem with the code that they convert the Excel into, and we have no ability to control it. The tools that we are going to use in this class will be able you to see how they overcome it. So what is so charming about bubble chart? Why is it so? It, first of all, for me, aesthetically is beautiful. It is the idea that we are able to display more dimensions of the data using the size and the color, the texture, and of the bubble inside in order for us to do that. And as you saw in the first video, one of the things that you saw is the ability to display that. Ring chart is another way for us to show distribution. Example, categorical distribution. And something that is really hard to produce in Excel, you will see how easy it to produce in other tools and how they produce it. But behind the data and behind the visualization, there is the framework, which is the statistics. And if you took my statistics class, we often talk about two types of statistics: description and inferential. Description is the idea that we are collecting, presenting, and describing the data itself. Inferential statistics is help us to make better decision based on the conclusion about the population by taking a sample. So the idea that nowadays, when we have the oncoming election and we're going to learn about how they predict who is going to be the next president, they're going to use more and more sample in order for them to predict who is going to win the election. So, example, a recent study examined the math and verbal GRE score of high school, and this is the mean, and this is the variable, the mean in math, and the mean verbal score in both ways, and how it applied together in order for us to do that. So the objective or the idea of statistics is the idea of population versus a sample. A population is the entire set or all the objects that have been analyzed. It's called population. In comparison, a sample, in order for it to be a good sample, it needs to represent the entire population, and something that is really important. Inside those two big terms, we have a variable, we have the experiment, and we have the statistics in order for us to help us to understand or interpret the data that we use in our analysis. So, example, a college dean is interested in learning about the average age of the faculty. Identify the basic term in this situation. The population is the entire faculty. A sample, if they took a sample of the faculty, a variable can be, example, age. And the experiment is that they take a sample of the faculty in order for them to learn about the average age, or they can take a sample using statistics in order for them to understand what it is. In that type of example, faculty as a variable, we have two types of variables: categorical and numerical variable. Categorical usually apply to the idea of describe the population. Example, professors. Usually they are not like to smile, they have angry faces, and they don't give nice words. This is categorical description. Numerical does not examine that. It is an idea that we are talking about how we describe it based on the age, not matter of their character, not matter of their faces. We are not concerned about that in numerical classification. So I'll let you example here of identify each of the following characters as attributes or as numerical, and the residence hall for each student in statistical class is the amount of gasoline pumped by the next 10 customer of the local Walmart store. And all of that are part of how we look at the data and how we see it. My own vision and my own thing is that we are thinking through our eyes. And this is something that we need to understand and comprehend and try to tell a story through this visualization to tell the story of the data. So according to our textbook, 70% of our body senses is based on our eyes. And so a different definition, according to Coin Ware, we should be interested in visualization because human visual system is a pattern of seeking of enormous power and stability, which means that we are looking at in our eyes in order for us to do that. Okay, so now we're talking about the power of visualization. There's two examples that our textbook provides. One is a table, and the other one is a visual of the table. So man versus woman and the sum. And if you will be asked what works best for you to understand what it is, yes, the visualization is lack of specific. It does not have details that give us more understanding in comparison to the table that is universal. And this is one of the problems of visualization. We do not have a universal language that we learn. We learn visualization by looking to pronounce the variable correct, to write a sentence correct. What we do is teach you visualization and hope that you will be able to understand the structure of the visualization. And in this case, I hope that is a clear case that both can display or provide more information. So how the visualization basically work? We have eyes. We can see the actual image, what our eyes see and what goes to the brain, and the final image is been captured. So this is how the process goes into the physical body in order for us to do that. How the visual perception works. Basic figures versus background. And so the issue is that on most basic issue in visual perception concern how we look at some scene of the image and figure out what is the image is based on the background or based on the contour of the image itself. So the edges and the counters are usually critical in the respect of usually give us more information about the image itself. But what about ambiguous images? This is where the art come into play, and this is something that we will need to deal with, and especially when we are trying to create something more powerful or more artistic, and something that we will learn how to adopt that and try to give more directions to the user to see that. So the issue is perspective. That is usually ability is the picture on the left of a young stylish woman or the older woman. This is where we can help in order for us to make this visual more transparent. And this is something that we are different from artists, that his role is to play with our perspective. In our role as a visualization people, we like to be more transparent. So this is the issue that we needs to apply to. One of the basic rules in provide more in-depth and transparent visualization is called the Gestalt laws. And the Gestalt law is based on a German language, which means patterns. And it is the idea that all mechanism of the sense has some patterns that they are trying to do. So it is basically the law of simplicity. How can we make this visualization more simple in order for us to succeed to communicate our data analysis or our capture of the data in more transparent way? So in that law, there's terminology that involve. Proximity is how things are close together, give us the sense of that they work together. There has some partnership or relationship. So the rule of the Gestalt is that the best way to emphasize relationship between different types of entity is to place them in approximately in a display. So the idea here is again display as approximately in order for to show the collection. Similarity is another terminology that this Gestalt rule came up with. And similar item, the shape or the colors are grouped together. So it basically combines separate dimension to assist the visual segmentation. So the rule is related visual elements should be look similar. Look at example A versus example B and see how it goes together in that example. Continuity is how people most likely to construct the visual grouping out of the elements that are both smooth and continuous rather than one that contain a destruction or change in direction. So apply connection to show relationship, which means that this is example of connectivity, and this is where we can apply it and examine it. Connectedness is another example. Show the connectedness of those examples to illustrate that. Symmetry is another way to emphasize relationship. Use symmetry to relate visual elements. Example, this is an example that we will see how to apply and what is it apply in that sense. Closure is another way. You may look at for closure in a lot of sense. When we read a book, we're talking about closure of the character or the narrative, but we also have that in visualization. So we usually have segmentation in the visual space that organize the segment of religion is stronger than proximity, and in this case we are like to do that in use this segment visual space, group similar elements. Example, A and B or C in the bottom. Relative size is also part of where our vocabulary come into play when we usually try to show the perspective as an object in order for us to do that. Figure and ground is usually what is the foreground and what is the background. This is something that we apply to, and when we combine other laws of segmentation to the image, example, the background versus the foreground, we give some space for us to maneuver and create a more concise way to be transparent with our visualization. Counters is also when we don't really know what really exists, and this is our ability to show some dimension. It is often used in weather. And why do they use that? In order for them to show that there's a shift in the wind or the hurricane, and they don't know exactly where it will hit specifically points. So they use that terminology or visual terminology in order for them to show the direction. Transparency is the idea of a good continuity and color corresponding exists, and this is something that we will learn to do throughout the semester. Overlap is another design platform that we can use, and again the two patterns can be combined in order for us to show some similarity. Patterns in motion is again the idea of how it works and how to apply. There's limited and difference element and how we apply them into motion. Very attributes to make the correction easier and how to apply to it. Form and counter in motion is also part of how we design or how we play with the design in order for us to show that. We also have the idea of frames. And we will talk about frame as a way for us to organize the design. We will learn frames when we will learn about animation, and we will see how we play around with animation and frame when we are trying to make a point about our data analysis. So this is, again, we are moving from one dimension of the design to the space and the movement of the visual object in order for us to make, again, a claim about the data. Causality is another way for us to do that, and again, the use of specific motion in causal relationship in the data, and this is something that we often use. We will see in correlation analysis how they display causality in that and how to apply that. Animate motion, again, the idea of animate the motion itself and how to observe it and how to apply that. There will be a module that will be specifically addressed to animation. Other figure, 3D and figures is also very stylish. Most visualization, all the visualization scholars do not like the 3D. They have problems with that. Even our textbook do not like that, but we will see how we can create that in open source environment and maybe learn how to apply those common ground of design in order for it to become more transparency. In graphic design compared to data visualization is the issue of repetition. And repetition is the issue of that we are using line, shape, images, texture, and on repeatedly in order for us to focus on what is the main point of this image. We will try to learn about that throughout the semester, and we will try to see if we can use repetition in order for us to make the point. So attributes of good design: the form, the color, and the motion, and that's from our textbook in page 36 or 39. And again, the length, the width, the orientation, the size, the shape, the blur, and everything else that goes on into the design itself is part of the terminology in order for us to create a great design, a great visualization that captures the data. We have pre-attributes, and that is really important: the width, the size, the intensity, the blur, and how we apply to it from the intensity of the color, darkest, and is usually the greater. And this is something that is the terminology, the grammar. I will call it the grammar of visualization and how to do that. So again, the issue of blocking the building blocks of information or data visualization is the visual perception, the quantitative reasoning, and information visualization in order for us to create great visualization. Okay. So I talked about the theory behind the visual analytics and what does it consist. But in order for me to, again, it's not only about the theory that most of other instructors talk about. I like to give you hands-on on the design itself. And so we are going to learn today about geometric information with data. What is geometric information? Usually it's about information of data about geometric location, about human and physical characteristics of location. It is about the geometric activities and condition of humans who live there. So in that definition, we often seek relationship or patterns and connection with a specific information. So the maps and the image has patterns, the graph has to have trends and relationship, the data has to be sequence or correlation, the text has to provide explanation in order for us to do that. We are going to look at two examples. We are going to look at Google data search, and it is the idea that giving us the data straight ahead. It's usually the new definition. In the past, Google has changed the format and they are continuous improving the interface in order for us to search data that be able to convert. And so in the past, they used to convert the data automatically with the technology. They stopped doing that. So instead, they are giving us a data set. This is the address of the data set. It looks something like this. Hold on. This is the website. And you can search whatever you want to, and you are looking for specific data set. You're not looking for the most popular. You're looking for a data set that you can download to your computer or save it on your Google Drive or any other drive. So example, when I came to USF, they asked me to show why is it so important to have Google work so hard in this data set search capability that they provide. So I searched Florida public library addresses, and I came with different ability to apply, and it gives you example, specific domain and specific location of the data set. One of those data set is the ArcGIS Hub that allowed us to apply. It gives us the API, and I'll talk about what is API and how do we create that, but it also gives us the idea of data. So we can download the data and it will download. In this class, I also going to share with you this data set, if the computer will allow me, with this data set. It will consist of the data set of all the libraries and the name of the county, the name of the library, and the address and the phone number. So what we are going to do, instead of copying the visualization that they create, we are going to do that we are going to save it in Google Drive, and we are going to use how to explore the idea of it. So in this example, I showed you the table of Florida library in Google Drive, and it consists of the name, the library, and we are going to use Tableau. What is Tableau? Tableau is supposed to be the next generation of Excel. It has some things that is good. There's things that it's not good. One of the things that is not good is that you need to download the application to your desktop. In this case, this is the application. It allowed us, if you're going to look closely, you're going to see connect to Excel file, to a text file, or Google Sheet, or any other sheet that you are looking at, and it will give you the ability to create that. There's another aspect of Google Tableau that is good. What I ask, and I will repeat asking about that you will not download the entire application. You will download the public Tableau. Why is that? Because you will have a space that you'll be able to display your visualization. You will be able to upload it on the browser in case you do not have space on your desktop or your computer, and it will give us the ability to see libraries feature and what features it include and how other people look at the visualization. So it is a fun thing to do, and we will learn about that. One of the things that Tableau is very good is helping you to sort the data, and this is important. Why? It gives you the columns and the rows, and by using that, you are able to see what is your priorities with regard to visualization that you want to display. For me, as a visualization guy, I usually like to apply the Tableau as the first step in my visualization, just to see how it goes about. It helped me to define the colors. Example, I can add more dimension to the colors. Example, I can create water, I can create greenery, I can create different colors to the points compared to the standard visualization, and be able to add more dimension. So again, I want you to test your map, see if it makes sense, add dimensions, example, the location or different city or county that is important to you, and test it. It's just the way for you to learn about this tool, about Tableau graphics and how to apply that, because next class we're going to start talking about Adobe Illustrator. And Adobe Illustrator is a little different from Tableau because it's not designed to analyze your data. It's more about the design itself, the final touches of the graphic design. And just a reminder, I want you to download it before ask to download it from USF. You can do that for free. You will get access to Adobe Cloud, and we will use Adobe Illustrator as our way. So this is it. In your assignment, you will search and collect data, personal, public, or something of your interest. You will use Tableau to in order to convert your data into geographic map, and then you going to post it on your blog and submit the address of your blog on the posting to Canvas. So you're going to give some description and you're going to apply that. I hope it makes sense. I hope you enjoy that. I will also include in the Canvas a lot of information about the instructions and how to apply that. I hope it makes sense. I hope you will ask questions. Until then, enjoy.